Hi everyone. Today we are going to deal with a new topic, that is equivalence of finite automata. What do you mean by equivalence of finite automata? You will be given two DFAs or NFAs and you must to prove that whether these two NFA or DFA are equivalent. Now I am giving here two DFAs. So by this problem I will provide you the method how to prove these two DFAs are equivalent. Before proving into the equivalence, first thing you have to take care of is the thing in the minimization of automata, whether there is any trap state is there, so you can avoid it. In two DFAs, whether any trap state is there, you can avoid it. Means whether two trap state is there, you can club. More than two trap state is there, you can club and make it one. So every time when you look for the equivalence of finite automata, you look for the minimized automata. This automata must be minimized and this automata must also be minimized. This is a sufficient condition. It is not a necessary condition. If you are not provided with the minimized automata, then also this method will work. But for simplicity, you must make it a minimized automata. Then the procedure will be very simple. So this and this is a minimized automata. Procedure is this: take the start state of the first automata and start state of the second automata. So we are making the combination start state of the first automata and start state of the second automata. So start state of the first automata is Q1 and start state of the second automata is Q4. And symbols, what all symbols we are using here? Here we are using two symbols, C and D are we using. So here it is D. Okay, I didn't mark here. This is D here. So C and D are the symbols we are using. Okay, then Q1 on C goes to Q1 on C goes to itself. So Q1 itself. Q1 on C goes to itself. I didn't mark here. Q1 on C goes to itself. So here Q1. Q4 on C goes to itself. That is Q4. Okay, so I have made the transition for C for both states, that is Q1 from the first automata and Q4 for the second automata. Next, look at for the D. Q1 on D goes to Q2 and Q4 on D goes to Q5. Okay, so Q1 on D goes to Q2 and Q4 on D goes to Q5. Okay, so likewise the condition in the equivalence of DFA and NFA, you must look here whether these two states has been visited. Q1 and Q4 has also already been explored. So what to be explored? Q2 and Q5. If this state is not explored, first take this state as the rule in the equivalence of NFA and DFA, that is you already studied. So you must explore what? Q2 comma Q5. Okay, so Q2 on C goes to Q3 and Q5 on C goes to Q6. Okay, next one you say Q2 on D goes to Q1. Q5 on D goes to Q4. Okay, so this has been visited, this has been visited, now this is not been visited, so this has to be explored. So Q3 comma Q6. Okay, so Q3 on C goes to Q2. So Q3 on C goes to Q2 and Q6 on C goes to Q7. Okay, so Q7. Okay, next one, Q3 on D goes to itself, that is Q3 itself. Next one, Q6 on D goes to itself. Okay, I didn't mark here. Q6 on D goes to itself. So Q3, Q6. Okay, look at here. This has been explored. This to be explored. So next I have to explore this Q2 comma Q7. Okay. So next one, Q2 comma Q7. So Q2 is here. Okay, so Q2 on C goes to Q3. So Q2 on C goes to Q3 and Q7 on C goes to Q6. Okay, next one, Q2 on D goes to work Q1, Q6 on D goes to Q7 on D goes to work Q4. Okay, next one, Q3 Q6 we have to explore. So Q3 and Q6 is already been explored. No states have to be explored. Okay, so look at this transition table. You must check whether any combination with final state and non-final state is coming. Okay, so Q1 and Q4 both are final states. Okay, next one comes Q2 and Q5, Q2, Q5 non-final state. Next come Q3, Q6. Q3, Q6 is also the final state, non-final state, and Q2, Q7 also non-final state. So these two automata are said to be equivalent. When it is not equivalent, if there is a combination comes in your transition table like that, finite state and non-finite state combination comes, these two automata is said to be not equivalent. Okay, so that is the condition. If in your transition table when you do like this, your combination if comes like this, finite state and non-finite state, this is said to be not equivalent. Also check whether all state has been visited. So Q1, Q2, Q3 has been visited. Here Q4, Q5, Q6, Q7. Here all state has been visited. Here all state has been visited. And also there is no combination like such, finite state and non-finite state combination. Then this automata is said to be equivalent. If in the both the condition, if any state has not been visited, or if there is a combination like such, finite state and non-finite state is coming, then this two automata is said to be not equivalent. Okay, thank you.